Okay, so in class, I was working out this problem and I made some errors along the way. So the answer I got, I'm confident, was not correct. So I'm going to go through this problem and I know now that I have the right answer, so you'll be able to see how to solve a problem of this type. So this is a typical combustion analysis problem. They gave you the composition, well, not the composition actually, they gave you the mass of the original compound. The compound is burnt in oxygen. It produces this amount of carbon dioxide, this amount of water, and the question is asking for the empirical formula for the compound menthol. So let me go to my writing pad here. So first thing I'm going to do is I'm going to start off with the given mass of the carbon dioxide. I'm sorry, yes, the carbon dioxide, which is 0.2829 grams of CO2. And what I'm going to do is find the mass of carbon in the carbon dioxide, because that is going to be equal to the mass of the carbon in the original compound. So, of course, we need to convert to moles first. So you're going to have 1 mole of CO2 above. And the molar mass of carbon dioxide is 44.01 grams, all right? And then we do the conversion from moles of carbon dioxide to moles of carbon. That's a 1-to-1 ratio. And then we do the conversion of moles of carbon to the mass of carbon by using this molar mass conversion factor. So that's going to cancel out with this with this with this, and you get your answer after computation. So 0.2829 divided by 44.01 times 12.01, and according to my calculation, this gives the answer of 0.07720 grams of carbon, all right? And then I'm going to do something similar in the case of starting off with water. This time I'm going to figure out the mass of hydrogen. First, we have to convert to moles. So you're going to have 1 mole of H2O above the molar mass, which is 18.02 grams for water. And then we're going to convert from moles of water to moles of hydrogen. And as I said in class, this is where students tend to make their error. They forgot, or they will forget, to make sure that it's 2 moles of hydrogen per 1 mole of water, and that's because you have the subscript of 2 here in the formula for water. It's a very common error that students tend to make. Okay, so the next step, of course, is to go from moles of hydrogen to the grams of hydrogen, 1.008 grams of hydrogen. And when I worked that out, I got 0.01297 grams of hydrogen. All right. Now, you recall in the question, let me go back to the question. The question told us, okay, why is this thing not responding? Oh, I see why. Okay. So the question says that the compound contains carbon, hydrogen, and oxygen. So far, we have determined the mass of carbon and hydrogen, and we can now determine the mass of oxygen because we have the total mass of the compound. So the next step, okay, is to determine the mass of oxygen. Mass of oxygen. And according to my calculation, that would be 0.1005 grams, which is the total mass of the compound, minus the sum of 0.07720 grams plus 0.01297 grams, all right? Because this is the mass of the carbon, this is the mass of the hydrogen. We subtract that total from the original mass of the compound. And when I did that calculation, I got 0.01033 grams. So now we have the masses of the 3 elements. So the next step is that we need to determine the empirical formula. So how do we do that? Well, just like we did before. Let me just get out of this here. what I'm going to do is construct a table where I have carbon, hydrogen, and oxygen at the top. Draw my lines separating everything. And the first thing I'm going to do is write in this row the masses that we just calculated. So in the case of carbon, that would be 0.07720 grams. In the case of hydrogen, that would be 0.01297 grams. And in the case of oxygen, it would be 0.01033 grams. So as we did before in a table like this, the next step would be to get the moles. So to get the moles, we divide each of them by their respective molar mass. So in the case of carbon, 0.07720 grams multiplied by 1 mole over 12.01 grams. Do the same thing for the hydrogen, 0.01297 grams multiplied by 1 mole over 1.0808 grams. And then finally, in the case of oxygen, we take the 0.01033 grams and multiply that by 1 mole over 16.0 grams, 16.00 grams. So I did these calculations already. So in the case of the carbon, I got 6.428 times 10 to the minus 3 moles. In the case of hydrogen, it is 0.01287 moles. And finally, in the case of oxygen, it's going to be equal to 6.456 moles. And then the next step, of course, is that we examine, this should be times 10 to the minus 4. Can't forget that. And then we're going to go through each of these and see which one is low. This would be the lowest of the 3. So you're just going to divide right through by the lowest of the moles, which is 6.456 times 10 to the minus 4 moles. So this is going to be 6.428 times 10 to the minus 3 moles. It should be minus, divided by 6.456 times 10 to the minus 4 moles. And then in the next one, it's going to be 0.01287 moles divided by 6.456 times 10 to the minus 4 moles. And then this would be, of course, when divided by itself gives you 1. So when I worked out this one, I got 9.956, which of course will round off to 10. And in this case, I got 19.93, which rounds off to 20. So therefore, the empirical formula is C10H20O. And that's basically how that is done. All right. Okay, so